Hi, this is Grant Imahara here at the Sensus Testing Labs to find out, is a mesh communication network really faster than FlexNet? All right, Greg, so a popular idea out there is that mesh communication networks are the fastest available. Is this true?
Grant, no, that's not true. And let me give you a visualization that'll help you understand just the differences between a mesh network and our network that we call the FlexNet network.
Okay.
If you can imagine a Plinko board.
Okay, I got it.
With all of the pegs in it, and then you've got the chip that you drop, and typically the game is where it drops, that's how many points you get or whatever. In this case, just imagine that it's just a race to the bottom. And in the case of mesh, what happens is that you drop the chip and it bounces from peg to peg to peg to get down to the bottom. And that's exactly how their system works. It bounces from endpoint to endpoint to endpoint to get to the collector and to the head end.
Okay.
Now, imagine that same Plinko board, take out the pegs, and that's FlexNet. So for every application that a utility uses on FlexNet, imagine dropping that same chip down, it's going to go directly to the bottom and much, much faster than you would with a mesh system. Every application that runs on FlexNet has its own dedicated Plinko board that enables no interference, direct communication from the collector down to the endpoint and from the endpoint back up to the collector.
Now, are there any other factors that affect the speed of a network?
Well, there are a couple different things. One is the spectrum that you operate in. For FlexNet, what we do is we operate on FCC, primary use, licensed spectrum. And that means that we're the only ones that are transmitting and receiving on that band. Whereas if you look at mesh operates in an unlicensed frequency. And that unlicensed frequency, anybody can develop a product to operate in that frequency.
Like
which
what?
means baby monitors, garage door openers, cordless phones, Wi-Fi routers, and all of these things are operating at the same time they are. That's why they have to end up going from peg to peg to peg in order to be able to get the signal to the collector and head in.
Anything else that will affect?
Another thing that we do, and I talked about the channelization piece, we can channelize data. So every application has its own spectrum, has its own frequency that it operates on. We also separate uplink and downlink channels so that you can transmit and receive at the same time, which is called full duplex, versus our mesh is half duplex. It has to transmit and receive on the same spectrum.
So it sounds like you've got a dedicated frequency spectrum and different types of dedicated paths for different types of data.
That's it exactly.
All right, Greg, I hear you, but I'm a data guy. I need proof. How can you prove that FlexNet is faster?
Well, let's look at the math. That's really where the rubber hits the road. You look at the math and compare the data rates between mesh and between FlexNet, our communication system. If you look at the math, what it will show is that FlexNet, with all the channels that we have, has much higher data rates than mesh does. It also will show you that mesh really starts bogging down the more Plinko pegs it has to hit in order to get to their collector and to their head end.
Well, I'm not going to argue with the math. Thanks a lot, Greg.
Yeah, thank you, Grant.
So, moment of truth, fact or fiction. Mesh communication networks are the fastest available. I have to say this one's clearly fiction. Based on all the features that FlexNet has that are individually targeted towards different problems, as well as the math, which you can't really argue with, FlexNet is faster.